All right, so this is May 2019, question number 3b. It says triangle ABC with vertices A 1, B 1, 4, and C 3, 1 is shown in the diagram below. Then we're told triangle ABC is mapped onto triangle LMN by a reflection in the x-axis followed by a reflection in the y-axis. It says on the diagram, draw and label triangle LMN. So we have to reflect first in the x and then reflect in the y. So if we reflect in the x-axis, the x-axis being a mirror line. Now in a reflection, the object and the image are the same distance from the mirror line on either sides of the mirror line. So if A is here, it's 1 unit above. B would be 1 unit below the mirror line. Sorry, A prime would be here. So this would be A prime, which is the image of A. C is also 1 above. So this would be C prime. Then B is 1, 2, 3, 4 units above. B prime would be 4 units on the other side of the mirror line. So B prime would be 1, 2, 3, 4, which is here. This would be B double prime. Sorry, B prime. No, we don't need to draw this because we're not told to draw this. We're told to draw LMN, which is what you get after you reflect 2 triangles. So if you wanted to, I don't think it hurts, but let's not reflect it for the time being. Now, I'm going to reflect A prime now in the y-axis to get L. So if I reflect A prime, A is 1 unit from the y-axis. L would be what? 1 unit from the y-axis, but on the other side. This would be L. B, the reflection of B prime in the y-axis will give you M. B prime is 1 unit from the B prime is 1 unit from the x-axis, from the y-axis. So M would also be 1 unit, but on the other side. I'm reflecting A prime, B prime, C prime in the y-axis. This is M. The reflection of C prime will give me N. C prime is 1, 2, 3 units on the mirror line. N would be 3 units on the mirror line on the other side. 1, 2, 3. This is the image of C prime, which is N. Now, all I have to do is to use my ruler and my pencil to connect the vertices. So we're asked to draw triangle, we're asked to draw a triangle LMN, which is the image of ABC after a reflection in the x-axis followed by a reflection in the y-axis. So we did that, all right? So some points to note. C, which is 1, 1, became N, which is C, which is C, which is 3, 1, became N, which is -3, -1. That's all we needed to note. So in this transformation, the effective thing that happened is that the signs of the x and the y coordinates change. The signs of the x and the y coordinates change. All right, so let's turn the page. Now, next we're asked to describe fully a single transformation that maps triangle ABC onto triangle LMN. Let's go back to it. I want you to have a look at this and tell me which transformation is going to map ABC onto what? LMN. All right, I can tell you what it looks like to me. To me, this looks like a rotation of 180 degrees. So I'm going to say triangle ABC is mapped onto triangle LMN by a rotation of 180 degrees about the origin. All right, now this is represented by this, or this is the same as saying R O positive or negative 180 degrees. And all that this is emphasizing is that if you rotate 180 degrees in an anti-clockwise direction or 180 degrees in a clockwise direction, both are going to carry to the same spot. So if I turn 180 degrees to the left or turn 180 degrees to the right, both turns will take me to the same point. The last thing, state the 2 by 2 matrix for the transformation that maps triangle ABC onto what? Triangle L prime, M prime, N prime. Now, is either you're going to understand this or you're going to have to swat it. Now, RO is actually this matrix. Now, here's what I do. I understand it, so it's easy for me to reproduce it. What I notice is that in my 180 degree rotation, the X and Y coordinates stay where they are, but their signs change. Now, the matrix that's going to cause the coordinates of a point to stay where they are is this matrix. It's the I matrix. This matrix will cause what? The coordinates of a point to stay where they are. This will change the sign of the X coordinate, and this will change the sign of the Y coordinate. Ladies and gentlemen, this is the 2 by 2 matrix that represents a 180 degree rotation. In a 180 degree rotation, the X and Y coordinates stay where they are and their signs change.